what is a robot? Can we redefine what a robot is? Now, the vast majority of the robots in storybooks and deployed in industry today are inspired by the human form. We have humanoid robots, we have robot arms, we have boxes on wheels. But nature comes in a much wider range of shapes, and so does our built environment. And so an interesting question is, can we turn any shape into a robot? My name is Daniela Rus. I'm a roboticist. I'm a professor of electrical engineering and computer science at MIT. I'm also the director of the Computer Science and Artificial Intelligence Laboratory at MIT. CSAIL has been at the core of advancing technology, of advancing AI, machine learning, robotics, and what they can accomplish since the very beginning. CSAIL researchers were among the pioneers who gathered together to think about what the future of academic studies might look like. And that's when, in 1956, they coined the term artificial intelligence to denote the study of machines with human-like characteristics in how they move in the world, how they learn, how they play games, and how they reason and how they make decisions. And so our researchers have been on a path to advance the intelligence of machines, what machines can do ever since. And as such, at CSAIL, we cover a broad range of activities about AI, machine learning, and robotics. In AI, we are working on understanding what today's technologies can do and making them better. We are working on bringing explainability to deep learning. We are working on a range of applications for deep learning. But we are also working on creating new models for machine learning that are more powerful than the current models that are being deployed today. We are also working on the hardware side and on the brains that enable machines to move in the physical world. So we are advancing robotics by considering how to build new robot bodies, how to build new robot brains, and how to bring the machine and the humans in harmony, how to create better human-machine interactions for machines that adapt to people rather than the other way around. And within each of these areas, we have a lot of faculty and students working to advance what is possible. You can think of our work as going from science fiction.
Ah, it's a phone. I'll get it.
Morning, George, dear.
And then reality. And this is important because while today we all have smartphones and we have computers that help us broadly with number crunching work, in the future, AI, machine learning, and robots will help us with cognitive and physical work. But this means we have to advance the science and engineering of autonomy and the science and engineering of intelligence to create the kind of machines that will be friendly to people, that will be assistive and supportive for people, that will augment people with the tasks that they need help with. In my own research, I'm very excited about building soft robots. So soft robots are unique because they will usher in an era where machines and people will be able to work side by side. If you think about the current use of today's robots in industrial settings, well, we have these machines that are masterpieces of engineering that can do so much more than humans can. But these machines stay isolated on the factory floor because they're big and heavy and dangerous to be around. What we want is machines that are safer and that can work side by side with people. And I'd like to observe that in nature we have organisms that move in much more fluid ways, much more compliant ways, much more adaptive ways than the grand industrial robots. And so in my lab, we are working hard to bring this vision of a soft robot, of a robot that is made out of materials that are much more like skin than the industrial robots, that in turn would be more fluid, more compliant, easier and safer to be around. So we are trying to get our robots to be more capable. That means creating better brains for the robots. And part of that work involves figuring out new ways in which the robots learn. And to this end, we are working on a new class of machine learning algorithms that is inspired by what the biologists have discovered when they studied the brains of small creatures. So we have a new class of algorithms that are very powerful. And then we are also developing some task-specific applications. For instance, we have robots that will do your recycling, and we have robots that will do your grocery packing, and we have robots that will follow you like a guardian angel and support you with situation awareness as you move in the world. We have robots that swim, we have robots on the ground, we have robots in the air. We're looking at all kinds of machines that could come in to help with a wide range of tasks. And the third piece is thinking about how the machines can adapt to humans. For example, we're looking at whether it's possible to instrument the body of a person using muscle monitoring sensors, and from those signals, whether we could understand the intent of the human and then connect that to a machine who can come in to help the human, much like a colleague or a teammate would come to help you when you're trying to lift a heavy box and you're not making much progress. And so this is how we envision the future of machines that adapt to people, machines that support people with a wide range of cognitive and physical tasks.